Good morning. We discuss lecture series about photonics. So now photonics, we know current can be amplified by a vacuum tube or transistor amplifier. So similarly, light waves can also be amplified and termed as laser. So which is an expansion for laser light amplification by stimulated emission of radiation. So after the discovery of laser, so by Th Myman in 1960, rigorous analysis were made, so which lead to many types of laser got due to the lasing action with atoms, ions, molecules, etc. in gases, solids, and liquids. So the light beam from laser has a frequency up to 10^14 Hz, leads to many applications in the scientific world and showed that the functions of optics is alive. So next, properties of laser. So first one, highly monochromatic. So the laser beam is highly monochromatic, that is the wavelength is single. So whereas in ordinary light like mercury vapor lamp, many wavelengths of light are emitted. High intense. So since the ordinary light spreads in all the direction, so the intensity reaching the target is very less. So but in the case of laser, so due to high directionality, the intensity of laser beam reaching the target is of high intensity beam. For example, 1 millimeter watt power of helium neon laser appears to be the brighter than the sunlight. Highly directional. So this property, ordinary light spreads in all the directions, already we know that, and its angular spread is 1 meter per meter. So but it's found that the laser is a highly directional and its angular spread is 1 millimeter per meter. So for example, the laser beam can be focused to very long distance with a few divergence or angular spread. So that angular spread or divergence is given by pi equal to R2 minus R1 divided by D2 minus D1 degrees. So here where D1, D2 are any two distance from the laser source emitted, and R1 and R2 are the radii of the beam spotted at the distance D1 and D2. And next property is that high coherent. So it is an important characteristics of the laser beam. So in the lasers, the wave trains of some frequency or in the phase, that is the radiation given out, its mutual agreement, not only in phase but also in the directions of emission and polarization. So thus it is a coherent beam. So due to the high coherence, it results in an extremely high power. So due to these peculiar properties of laser, it has a wide engineering and medical applications. So next, conditions for laser action. So first one, population inversions, N2 greater than N1 in the atoms of medium. And second one is that the energy density of radiation on the medium should be increased. And the ratio of Einstein's coefficients should be less, A to 1 divided by B to 1 less than 1, so that the more stimulated emission to take place than the spontaneous emission. See, so now difference between ordinary light and laser beam. So we know that ordinary light, the angular spread is the more, and laser beam is the angular spread is the less. Ordinary lights are not directional. Laser beam is the high directional, and it's a less intense, and laser beam is the highly intense. For example, sunlight, mercury vapor lamp, these are the ordinary light, and laser beam is the helium neon laser, CO2 laser, etc. So thank you. So we discuss conditions for laser action in the next video.